So now we're given some different information here. We're given two sides and what turns out to be the angle between them. Because if I set up my triangle, I'm just going to try to be as accurate as I can here. Here's angle C. Now, we know that the side opposite angle C is side C. So that means these two lines that make up C must be A and B. Confused with the alphabet soup already? Yeah, me too. So this would mean A is 14, and this means B is a little bit longer, 16, so that's B. So we have this other side C, and these angles A and B. And this is what's called the SAS case, meaning side angle side. This particular case, since we don't know any opposite side angle partners, that I call that with law of sines, we need to use the law of cosines. And that's what we're getting into here. So the particular law of cosines that we're going to use here is c squared equals a squared plus b squared minus 2ab cosine c. Naturally, what you notice is this side over here, this angle over here. So if you have to find a different angle, there's three different versions of this formula. So we're just going to plug everything in. So I don't know what C is, but I know what everything else in this equation is. So I'm going to have 14 squared plus 16 squared minus 2 times 14 times 16 times cosine of 80. And I'm just going to take my calculator and do all of this because it is just punch and crunch pretty much. 2 times 14 times 16 cosine of 80. Notice that all just kind of stays together. There is my answer, well, my c squared anyway, 374 point dot 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 dot. And I'm just going to take that answer and raise it to the 0.5, which remember is square root. So to the nearest tenth, we have c is equal to 19.3. Okay, so I'm going to organize my info. A, B, C, A, B, C. So we were given angle C is 80, side opposite that is 19.3, and we have A is 14, B is 16. Now we have two unknown angles, and there's two paths to take from here. The thing to understand is that law of cosines always gives you a unique triangle. Law of sines, remember we had all those little ambiguities there. So my tip would be, if you started the problem with law of cosines, end it with the law of cosines. In other words, stick with it as long as you can. So I'm going to choose to find angle B first, and then once I find angle B, we know we can use the 180-degree rule to find A. So this is almost a done deal. Now, the version of law of cosines, now keep in mind the one we used, we had c squared on one side, angle C on the other. I want angle B in there, so I'm going to use the version that has side B on one side, and that just means that the other sides are over here. And there we have that. So we know everything else there is to know there, except we're going to be finding B, or cosine B, I should say, first. So little b squared is 16 squared. A squared is 14 squared. 19.3 squared minus 2 times 14 times 19.3 cosine of B. So the process is subtract, and then divide by this. So I'm going to do 16 squared minus 14 squared minus 19, whoops, too much there. 19.3 squared. If only the calculator was voice command, it'd be working out better for us now. So that's negative 312.49. And then I'm going to divide that by quantity, negative 2 times 14 times 19.3. And that gives us cosine of B. So cosine of B is equal to 0.5782, blah, 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 blah. And I know that B is the inverse cosine of that, so I'm going to do inverse cosine of the answer. And that gives me 54.7 degrees. So great. We have another angle, which means we can then find angle A, because we know that three angles have to sum to 180 degrees. So 80 plus 54.7 is 134.7. So that leaves us with 45.3 degrees. I'll just verify that over here. 180 minus 54.7 minus 80. And there it is, 45.3. And thus, we have solved the triangle. SAS case, law of cosines, pretty much a slam dunk. They're all going to be solved the same way. So you can basically follow that. Hopefully that makes sense. Hopefully that helps. And thanks for watching.